can't tell you how ecstatic I am to see
Yeah, it's going to be brave new world. All right, folks, it is 9 a.m. on Friday morning of IETF week. Congratulations, you have made it this far. And I know Friday morning is everyone's favorite part. So thank you for coming and sharing it with us. This is HTTPBIS. I'm Pat McManus. I have my back turned to many of you, and if I turn to look at you, I'm not talking into the microphone anymore, so that's a bad thing. But hi, my chair, Mark Nottingham, or co-chair, Mark Nottingham, can't be with us this morning, so gonna try running this solo. It's a brave new world out there. Okay, so we have the usual, the note well, it is Friday of IETF week, so the fact that that is inscrutably small should not be a blocker for you understanding what it says. It says basically anything you do in this room other than sitting still and being quiet is a contribution to the IETF, and we thank you for it. Will someone agree to monitor Jabber? And if you are saving up your volunteerism to work on the minutes, we already have someone who's volunteered to do that. So you can just pitch in and say you will help out with Jabber. And I can't see the people behind me, so just yell out your names. Yes. Oh, thank you so much, Barbara. So Barbara's going to take care of the jabbering. For the minutes, in the Jabber channel is an Etherpad link that we're going to take care of the minutes on. Hopefully that's a collaborative effort, but Hervé and Magnus have volunteered to lead that effort, help that out. The blue sheets are circulating, a required element. Just do them and move them on, make sure they get around. We can take a look at the agenda. If anyone wants to bash the agenda, this is the work we have in front of us today. Are there any comments? Excellent. It's a fairly full agenda if we use all the time. I suspect some of the drafts won't use their full 12-minute allotments, and we might have more room at the end. And Mark can't be with us today, so we won't be doing the retry replay presentation. So it's a little looser than perhaps than initially planned. Okay, so a couple of comments about format, because the chairs are seeking comments on the format of this meeting on two different tracks. So one is just, as you may note, this is a different meeting room than usual, and there are plenty of seats available at the table up front. And so if you think you might have anything to say during this meeting, it would be actually really quite convenient if you would come up and join us up here. And we'll see how this meeting works. I assume many of you were in Quick yesterday and experienced this format already, but I'm interested in your feedback on how this works. And the other thing is the content of the meeting as well. So we have we use largely the same format in Soul and thought it worked pretty well. And so what we're going to try and do on a regular basis is devote the bulk of our meeting time to the active drafts in front of us that the working group has chosen to adopt and is presumably, moving towards a happy disposition. Then we're also going to try and devote some of our time to talking about specifically the H2 relationship with the Quick working group, as that's part of their charter. And we're going to try and make sure we spend some time talking about that mapping during each meeting, because we think the expertise in this community is vital to making sure that effort succeeds. And if you've been in the Quick meetings, there are a lot of other topics as well as that one. So this gives a chance for those comments, I think, to breathe a little bit. So that's going to be a key part of this discussion. And then we're seeking also to do a segment in each meeting that I'm calling feedback. You saw Nick do this for us last time. Fang is going to do it for us this time, where we're going to bring in people to talk about actual implementation experience with things we have minted as standards, experimental standards sometimes, proposed standards other times. Talk about how that stuff is really working in the world to try and inform future work. So. And then we'll have sort of an opportunity for people to pitch future work if it's been sort of vetted on the mail list first. So that's like the big structure, and I think you can routinely expect to see it structured that way. So I seek feedback on that. I have graduation notes. So since we last met, we've had 2 documents sent to the IESG. It's like, right. So that would be 5987-BIS, thank you, Julian, and operative security, which, thank you, Martin. So that's really great. Finally, but it's not the finally I focus on, it's that it happened. That's, the important.
Yeah, let's be clear. This is a pretty important thing to have done, and I have to thank everyone who's reviewed it, provided comments, and those who have implemented it even. I think this is something that's worth having. Now it's only experimental, but I think it's worth having.
And so we have 8 active drafts on the agenda today, all of whom hope to reach such exalted status as those last 2. So with that being said, the first piece of work we're going to talk about that the working group has adopted hasn't seen a whole lot of active changes, but Mike West was going to join us remotely. The Medico screen is too small for me to read the names on. Mike, have you joined for a remote presentation?
I am here. Hello.
Oh, Mike, that's great.
Join the queue, please. Then Patrick gets to press the red button.
Yeah.
I have no idea how to do that.
Do you have video?
I'm trying to. Let's see. This is going to be exciting. I'm hitting buttons. Do I raise my? I raise my hand. I see.
There you are. Yeah, I think I don't even have to press the button because you joined in, presenter mode, which is awesome. So take it away, right? I don't believe there are no slides for me to show here.
No, there aren't any slides. This is a very short summary of what is going on from a implementation perspective, and then a mea culpa for the specification perspective. I'll go over the highlights first. We had 3 drafts that were adopted as part of RFC 6265 BIS. Those were cookie prefixes, a strict interpretation of secure cookies, and same-site cookies. Cookie prefixes shipped in Chrome 49, so in end of Q1 last year, and I believe they shipped in Firefox 48, although I'm not entirely sure. Also, I think last year in Q3 or Q4. Currently, we're seeing some good uptake of __ host cookies. Something like 0.004% of set cookie headers that Chrome sees are using host. Less usage is being seen for the __ secure prefix. We see something like 0.00001% of set cookie headers. Those sound like small numbers, but we see a lot of cookie headers. So even small numbers in percentage terms turn into a lot of cookies actually being set for users. We're seeing usage of these internally in Google, and actually in response to some red team activity inside of Google, we're seeing more usage of host cookies because, as it turns out, it prevents against session fixation by other things on your origin, which is kind of cool. Strict secure cookies is behavior that was implemented in Chrome probably about a year and a half ago, and we've been slowly rolling it out over the last 3 quarters or so. We ramped that up to 100% with Chrome 56, I believe, which was at the end of January. It looks like Firefox is shipping this behavior as well, along with Firefox 52, which I think just came out, 2-3 weeks ago? As far as Chrome goes, we haven't seen many bug reports so far. We have seen some developer impact, and we have seen some developers that are upset with Chrome because of the changes. Generally speaking, it looks like the volume of pain that we're causing to developers is low enough in comparison to the benefits that we're getting that it looks like this will stick. But it's still early days, and if anything huge comes up, we might have to roll it back or at least dial the percentage down. But as it looks right now, it looks like it's going to stick.
Yeah, I'll throw in the Firefox data point. You're right about that's in 52, which I think is 3 or 4 weeks old. And I do have a handful of bug reports from developers about it who are a little annoyed, but it's a small handful.
Yeah, and that's basically the same experience that we're seeing. The major concern that we're actually seeing, or not major, but the concern, the developers that people are pinging me about are actually WebView developers as opposed to web developers. So the people whose applications in Android have changed behavior. And for various reasons, Android is much more concerned about backwards compatibility. So there are conversations going on there. The last draft that we approved or that we adopted was same-site cookies. Same-site cookies shipped in Chrome 51, so that was like May-ish of last year. And we're seeing about twice as much usage of same-site cookies as we are host cookies, so the host prefix that I mentioned earlier. This is like about 0.01-ish%. It's a little bit less than that, but it rounds up to 0.01. Again, small percentage, but turns into a large number of cookies. We're starting to see adoption of this. I think Dropbox had a pretty good article posted just a week or two ago about their experience deploying same-site cookies. There have been a couple of other developers that have posted interesting articles talking about this. So I think it's starting to get a little bit of mindshare, which I think is pretty nice. We're also starting to get more bug reports for Chrome's implementation, which is great because it means that folks are actually starting to use it. So we'll improve that implementation over time. As far as the actual RFC, so we adopted these 3 drafts, and now we need to merge them into the RFC. I have not done anything on the RFC since like Q4. So this first quarter of this year, I did basically nothing, or at least nothing on this. I did too many other things. Q2 is where it's at, totally. So I do intend to get those docs merged into the RFC. I expect to be able to post an update to the RFC this coming month. So there will certainly be an update within the first 2 or 3 weeks of April. And then I'm hoping that by the end of the quarter, we'll have all 3 of these docs merged into a state where we can actually start diving into some of the details and making sure that the way that I think that we should solve them is the way that y'all think that we should solve them as well. So Q2 is where it's at.
How are you feeling about the issue list?
The issue list is not huge. I think that the main work that's left is actually to take the stuff that's in the docs and move it over. The issues that I think, and I'll admit that I haven't looked at the issue list in the last week. The issues that I've seen pop up are, I think, pretty straightforward to deal with. So at least on the one hand, the issues that I see in Chrome are pretty straightforward to deal with. And the issues that I've seen on GitHub are not, they don't worry me. It just means I need to take time to take care of them.
Does anyone have any questions or comments for Mike?
Yeah, behind you. One question, you quoted numbers, the stats about cookies. It sounded like you said there were a lot of cookies out there. Do you have stats in terms of impacted users, the number of users who actually interacted with said cookies as a percentage of total user base for your Chrome market?
Yeah, the numbers that I can get easily are the number of set cookie headers that we see. So that's the one metric that I know of. I think I can figure out how many individual users sent reports and try to give you some user numbers based on that, but that's not something that I can do easily right now.
No one cares. I'm Jim Roskin, the person asking the funny stat question. Sorry about that thing.
Thank you.
All right. I thought someone was trying to get to the mic and it was a blue sheet issue, just not tuned into the right stuff. Okay, so thank you, Mike. So what I think I understand on the draft is the recommendation is mostly stay the course. We've had a little bit of a pause, but this is still work you're interested in and have sort of scheduled in the near future.
That's
the first summary?
Yeah.
Right. Awesome, thank you. So next up on the agenda is going to be Kazuho. Going to talk about the early hint status. Oh, I have a clicker for you. Turn it on.
So I'm Kazuho, and let's talk about early hints. To recap, early hints is a mechanism for a server to notify what the headers are expected to arrive in the final response. So as you can see, 103 can be used to notify the link header that's going to appear in the final response so that the client can start fetching the resource before receiving the final response. And that gives us the time to optimize. And the changes we've had since Sol is basically 3. And one is that it has become a working group draft, and the internet track is experimental. And there has been 2 changes that has gone into the draft, and I'll explain them in detail. First one, it's about security considerations. And now the security considerations discusses what would happen when a broken client connects to a HTTP1 server that uses 103 early hands. And this issue happens when a forward proxy that multiplexes requests going to multiple origins into a single connection to the client. And as you can see in the example, the client issues 2 GET requests. And if for the first request going to example.com, the server returns 2 responses. One is the informational, and the second one is the 200 OK. And then example JP returns a 3rd response. So a legitimate client would consider the first 2 responses as the response to example.com, but a broken client might consider the second response that was from example.com to be a response from example.jp. And this causes a information leak. So this is a non-issue for HTTPS because the connection is end-to-end. And it is also a non-issue for HTTP too, because each request response pair is, the relationship is retained by the stream ID. So this point has gone into the security considerations, but since it's basically an issue of a broken client, we don't have any suggestions if you should use or should not use early hands with HTTP1.
Mike Bishop, I'm just thinking about this now, but wouldn't that also apply if a client is doing pipelining? Not that any do, but if we're talking about a broken client.
Yes, so this would affect clients doing pipelining and clients not doing pipelining as well.
Well, clients going to a proxy, regardless of whether they pipeline or clients pipelining to an origin server, could get confused about which of multiple requests the response goes to.
Right.
It's Roy Fielding, Adobe. To be clear, because the 1XX status codes can be extended by anyone, not just the IETF, this is an issue already for any client. If the client's broken, it's broken. It doesn't matter whether you extend 103 or not, because we can't, all you're doing is exposing a bug that already exists.
They'd have the same issue with 100 continue.
So let's go to the next issue, and it's about whether if the headers of 103 should be considered as part of the informational response, or it should solely be considered as a speculatively applied headers to the final response. And going back to the RFC 72331, it's just a may on whether if a header included in an informational response should be processed or not. And RFC 6265 also has a similar definition about the set cookie headers. So we have basically 3 options. One is to leave it a may, so that a header included in a 103 response may be also applied as part of the informational response, as well as being speculatively applied to the final response. And the other option is to specify whether applying a header within a 103 response is permitted or not. And in the 01 draft, I have specified that the client must not process the headers included in the 103 response as if they belong to the informational response. The reason I specified as that I wrote that is because I believe that having a well-defined behavior will benefit us in the long term. And because I believe that the most clients are just discarding the headers of an 100 response anyways. So if anybody could provide their opinions about this matter, I think it would be worth it.
It's Roy Fielding again. I have a little difficulty with that wording because it makes it sound like you don't parse the headers. And obviously you have to parse the headers in order to deal with the response chain. But I can send that on the list.
Thank you.
Looks like Patrick wants to say something.
It's just a general comment that I think you are at the core of the issue, whether or not you want to be explicit. And I think it's always a good idea to be explicit, especially when creating incremental functionality that this does. So that would be my inclination.
That's all.
So does that help? There are no open issues in GitHub. So there's this. So what's your feel for how this should progress, as a document in its status?
Mm-hmm. So this is the only issue I have now. And so if we could have a consensus about how we process this, then I think we could possibly go to last call if it's possible.
Does anyone have a comment on that?
I think we can move to last call even if we're thinking about issues inside the working group.
Mm-hmm.
It's just a kick in the ass after all.
Yeah, Martin Thompson. Roy had it. I suspect that what we want to do here is probably just tweak this thing, rev the draft. That's cheap too.
Yep.
And then say we're done with it.
Okay.
Yeah. This is pretty simple.
Yeah, I mean, I will huddle with Mark, but hopefully this is pretty simple, and we can have it sent to IESG before we meet in Prague. That would be a great success. Thank you for your work on this. This is
Thank you.
Something people really appreciate. Expect CT is next on the agenda. Hello, Emily.
Okay.
Did Kazuha leave you the clicker?
Sorry.
Leave it on there.
Okay, I don't have too much to say, so hopefully this will be brief. Just as a reminder, Expect CT is a response header that enables the site to opt in to certificate transparency enforcement and/or reporting. So this is something that user agents don't require today, but it's something that sites can turn on, similar kind of in the vein of HPKP, to have the user agent enforce stricter security requirements. Since Sol, there hasn't been too much work on the spec. I've been working on the implementation in Chrome. The main change to the spec has been the caching of report-only configurations. That was something that we heard from site owners was important to them. So making report-only configurations behave basically the same as enforcement configurations and get cached by the client in the same way. There's been a lot going on, shakeups in the trans working group, which has kind of affected our work. We want to, ideally, certificate transparency would be in a good, somewhat mature state before we allow clients to start turning on enforcement. So I thought I'd just mention a few of the things that are going on in trans that we kind of want to make sure stabilize before we would ship the implementation in Chrome. So one of the main issues going on in trans is sort of what a client should mean by certificate transparency, like whether a client should receive just SCTs and validate those, or we should go a little further and expect clients to receive inclusion proofs on connections. So basically, these are like, large architectural questions for CT that need to settle. I think they're kind of getting there, but I think we want them to settle a little bit more before we ship an implementation in Chrome. Another thing we'd like to do is have some kind of plan for automatically or machine readably distributing log metadata so that servers are able to basically find out when one of the logs they're using has been distrusted, and they need to start distributing new SCTs, because if they don't find that out, then they might have opted themselves into CT enforcement that is now breaking their users. So I think that's about it. Mostly just been waiting on things to settle in trans and working on the implementation in Chrome. Not too many changes to the spec. Any questions? Yeah.
I'm a little concerned that your expectations of trans are a little aggressive. I think you're not going to get out of them a consistent client policy.
Oh, I don't want a client policy.
Okay. Yeah, I think we're not going to get there. There's the workout going on in trans right now is to make sure that the various options you mentioned are all feasible.
Yeah, I mean, the main thing I want out of trans is, like, if we're going to give up on SCTs, then that would change things.
I guess I wonder how that distinction rises to the level of this document.
I don't think it rises to the level of the document. It rises to whether we would ship this in Chrome right now.
Okay.
So from the point of view of the document, we've got a couple open issues. Should we look at those? If we can close them right now, or?
The last I looked, I think most of them are editorial changes, so I don't think they can be closed right now. Oh, that's handy.
We can look at them.
Yeah. Those.
Going to follow them. The old repo, nice.
This is actually a rather tricky one, because this is useful for report collectors, but violates the same origin policy. This is a way the CSP has the same issue where if you send a report without a CORS preflight, this is not one of the whitelisted headers.
Right. Is there any comment on that? I mean, that seems won't fix to me.
Sorry?
Seems won't fix to me.
Yeah, I mean, Scott Helm will be sad, but that's fine with me.
So we can walk through these, or we can try and crystallize maybe what we think a plan for this document is. I mean, do we think, like, by Prague, we want this in last call? Should we block on trans? Should we? What do you think the right thing to do is?
Maybe Richard can comment. My sense is that things in trans will probably settle down over the next few weeks, and so last call by Prague seems doable to me.
Yeah. So I was going to say, Martin Thompson, I've had experience with dependencies in working groups, and I would encourage you to simply not have any expectations from trans at all, and simply be event driven on this one. So when Emily recognizes that trans is done, she can tell us that it's done and that no further changes are required here. If there are changes required here, then we will have to have a discussion about that.
I guess the other question is, to Richard's point, like, I don't know if anything in trans will affect the document. So I think the question is whether we need to have a shipping implementation before last call.
I mean, I guess there's some question of how precisely you want the semantic of this header to be specified. Right, if you want this header to presume some policy, but I don't think that's the direction the document's been headed.
Yeah.
So I think as long as you're not doing that, then you really don't have a dependency on the working group for the document. You might for your implementation.
Yeah.
And has Julian provided a review of this at this point? He's sort of the king of header syntax anomalies.
He commented on an issue, but I don't know if that means a full review.
Yeah, Roy again. I commented on this when it came up to working group review, and that it uses the cookie syntax, which is about the worst possible thing you can do in HTTP. I don't know why CSPs, I don't know why HSTS, or what I understand there's a background there, but it's a horrifyingly bad syntax. And it's not your fault.
What should the authors be copying and pasting instead?
What?
What should the authors be copying and pasting instead?
Any of the standard header fields will do. It's, or even make up one in, if you like. I mean, the problem, the cookie syntax is actually actively opposite all of the other header fields. We have to have a special exception within message parsers just to handle cookie.
So it might be helpful to file an issue with the specific objection.
Right. I should. I mean, it's on me to file an issue. I haven't gotten around to it yet. And the other question I had was, I still don't really understand why this isn't an option on certificates as opposed to a header field in HTTP, or some other whiz-bang way of sending an option through TLS instead of via HTTP. I understand that it may take more time to do that in TLS or certificates than it does to whip up a header field. But I mean, if we're going to do this, why don't we try to do it both at the same time and get rid of the header field as soon as we can?
I think I responded to that on the list that this is not something we want to live around forever. It's sort of a help CT get broader adoption mechanism. I hope that within the next few years, CT requirements in browsers at least will be mandatory, and there will no longer be a need for this header. So I don't think that this is the right place to fight that battle, because by the time a TLS extension or whatever gets deployed, there will be no use for it.
Okay, I mean, I understand the argument. It's just I don't believe it's actually a good idea to deploy header fields for a little while, because they end up being sent all the time anyways, even when they're not needed. But I can see where you're coming from. Can I at least ask you to minimize the header content to just what you need to indicate there's a problem, and either a well-known address to deal with it, or a link to just a short link on the site to where you get the rest of the information if there's a problem. Yeah.
Maybe we should. I sort of understand the suggestion, but not fully, I think. So maybe we can follow up on the list.
Yeah, we can.
All right, thank you.
Yeah, so Martin Thompson, regards to the syntax issue, it's number 316. If you refresh the page there, Patrick, you'll see that. We also have the header structure draft that's been adopted by this working group that actually goes through
what's next on the agenda, so it's quite the segue.
Right, which goes through exactly what you should be doing when you construct a new header field to be as close to possible as what we think is kind of okay. I mean, it's kind of the Wild West out there. This tries to sort of normalize things a bit. And so if you look at that document, it explains what it is that a header field should look like. And we also have a couple of other examples in recent documents that explain how to do this in maybe a less abominable way.
Mm-hmm. So I think that was a useful discussion. Do you feel like you're in a good place with this work and it's ready to move, continue to progress?
Yeah, I think so.
Excellent.
I had one more question. Sybil Langer. So it might, last time I think I raised this point where it might be useful for clients to indicate a header saying that they support this as well. So maybe in the future that might allow you to actually deprecate this header from the server, because echoing Roy's point of servers have no idea whether or not to send this in the future when CT is actually, when CT is actually being enforced. So I would like to know as a server operator that what is the what are the percentage of my clients that actually support this and how I'm doing vis-a-vis the percentage of those clients.
Would you mind filing that as an issue?
But yeah,
Thank you.
I have a comment from Jabber from Julian. It says, I don't think expect CT actually uses cookie syntax.
Well, then we might be able to close the issue very quickly.
Or Roy and Julian can huddle.
He may be right. I mean, last time I looked at it, it was before the proposal was sent.
The syntax hasn't changed, so.
The question may be whether cookies have syntax. Thank you.
All right, thank you.
All right, so the next one's a little tricky for me to navigate on the, a little tricky for me to navigate on the agenda because I think Mark was largely going to talk about this, but I will do my best to bootstrap it. So it's header common structure, which is a draft that Paul Henning has agreed to edit for us. Paul cannot be with us today. Header structure. And this draft is in a fairly early state. And so the chairs have had a conversation with Paul about the relatively slow rate of progress to find out whether he was still interested in this work, what his availability was, et cetera. And the answer fundamentally seems to be he's very interested in the work, but his availability is minimal and less than anticipated. So he's having trouble progressing that. So I think the fundamental we should have a short discussion here. Want to place those same questions in front of the working group to find out whether they think this work is still valuable, and I can anticipate the answer of that based on our last discussion. And if so, if anyone is interested in pitching in, we don't need commitments during the meeting, but you can reach me afterwards. So are there thoughts on this document, its status, its importance? There's a mic line behind me that I can't always see, sort of shout out if you're back there.
So I don't know what the procedural, Martin Thompson, I apologize. I don't know what the procedural basis is here, but I raised an issue a little while ago. We were having a discussion in another working group, and I forget exactly where that was now. But the issue was, what's the posture of this specification towards repeated parameter names? Right. Simple request. That issue was closed with a commit without any discussion. So we probably have a little bit of work to do there.
Noted.
Craig Taylor, I've got a comment from Mr. Nottingham in Jabber. I intend to make pull requests on this spec.
That's a commitment from Mark to actually work on this document. That's excellent.
Mark knows where the Meet Echo button is too.
Yes, but he may not want to speak.
Julian, do you have anything you'd like to add to this discussion? Jabber awaits you, if that's her. Okay, so
Julian says, not right now.
yeah, I think there's a lot of that going on. Can I get this comes up as a recurring problem, and I think there is consensus within the group that we want to do something about it. Can I get maybe a show of hands at how many people have read this draft that deals with that? Or an earlier version that said, So that's 5 or 6, about right? Okay. Thank you all. So the cache control response header immutable is next on the agenda, which is mine. So you get to listen to me a little bit more, but it's a very brief update. So we had consensus in Seoul to adopt this draft. As a reminder, this draft is essentially needed because a full RFC level document is needed to annotate the IANA registry with new cache control items. Well, yeah, go. No, on lots of stuff, go, man.
Martin Thompson, is that a problem, in your opinion?
I think for this, that was a little heavyweight.
Okay, maybe we can discuss that later.
Yeah. Yeah, Mark and I've had that discussion too. We have a lot of things that require full IETF review. But it is a brief and simple document, and we've, as a working group, have processed it pretty quickly. We adopted it in Seoul, or agreed to put it to the mailing list to adopt it in Seoul, and it's since been adopted. There's a new edition out that shifts the normative requirements onto the client instead of, about the behavior of the content on the server. It's the normative requirements shift to the client that they must not refresh certain types under certain conditions if they're compatible with this document. Language around the intermediaries was clarified. A whole bunch of editorial work was done, and it's seen significantly more deployment on the web. It's actually pretty widespread in a number of circles, and I appreciate that from a number of folks. It is my proposal that we are essentially last call ready. The current draft out there is an 01. There is a typo that like 4 people pointed out to me that we'll need to publish an 02 for, but it's purely an editorial change. And that's my update. So, are there any comments?
Ship it.
A number of thumbs up around the table seem to be the comments. Great. So next up, we have cache digests. So Kazuho's back up. We're doing pretty well on time, so don't feel pressed.
So about cache digests, the draft hasn't been updated since Seoul, but we have 2 new issues to discuss. And first one is about the overhead of calculating cache digests. And there has been a suggestion from Sebastian Deckers, who maintains the service worker version of cache digest using HTTP headers. And he had 2 suggestions. One is that there should be a suggestion in the document that you might want to dedupe URLs before hashing each of them. And that, personally, I believe that would make sense for some caches that holds various variants of representations tied to a single URL. And the second change he suggested was that instead of hashing the URL, it might make more sense to exclude the protocol and origin part before hashing the URL. And the pros is that since the hash part becomes shorter, the CPU cycles required to hash the values might become smaller. And the cons are that it is often the case that a browser cache uses a SHA-256 of the URL as the key for looking at the cache. And if we use SHA-256 of the URL as the key of cache digest, then that value can be reused. But if we switch to using path, then that kind of optimization might become impossible. So this is a pro-con issue.
Mike Bishop, I honestly don't know what our key is. I would have to ask.
So maybe let's go on to the next issue, and it's about O1 removal from digest. So this was raised by your advice, and the background is that it's somewhat difficult to maintain the digest of cache digest while updating the cache. And so he suggested using Kaku filters instead of golem coded sets for representing the cache digest. And the merit here is that you can remove a digest entry without rebuilding the digest. And so people might be interested in this, and I'd like to have feedback on this as well.
May I interrupt? Comment from Jabber, and I'm not sure if it was on the last slide or this one, but it's from Stefan Eising. Are browsers interested in this?
So I think that would be helpful, and not just browsers. If you could talk about state of, who's done experimentation, if there's any interop. I'm not really worried about bug interop, but just, these things are heavily dependent on like the way products are architected, right? So the feedback from different products and things that which you've gotten about both these design questions and the approach overall. That might help set the stage for some of these, very detailed questions. Could you maybe just brief the working group on, because I know there's been some work in service workers and things like that, maybe brief
Right.
folks on.
Now you mean?
Yeah.
Yep. So there has been at least one service worker implementation based on, and the server side is using Node.js, and the client side is using the service worker to implement this. And the cache digest is being sent over using an HTTP header. So the other issue we discussed in Seoul was that we should have an appendix on the cache digest draft explaining how cache digest should be encoded as a HTTP header. And we haven't worked on that yet, but my understanding is that it's a to-do thing.
Okay. Do you want to comment on Stefan's comment, or just what kind of interest you've been able to attract in this work?
I'm sorry?
So Stefan's comment on Jabber was essentially, what kind of interest have you been able to attract in this work? Do you want to comment on that, or?
So my feeling is that browser vendors are having difficulty finding time or wondering if there's enough merit on implementing this. On the other hand, server admins seem to be more interested in this, and they are writing service worker-based implementations. So I think that it would be a good thing to at least describe how this cache digest could be implementing using HTTP headers.
An additional Jabber from Stefan. HTTPD has support for header from first version, have not seen any client.
So Mike Bishop, I know we haven't set aside the time to implement this, but we are interested in it, particularly because we see right now pushes are blind. And a blind push is just as likely to be wasting bandwidth as it is to be useful to the client. So a service, we expose APIs to allow an app above our HTTP stack on the server side to push things at the client. Hardly anyone does because they don't know what the client has. And if we could actually put something in that says, hey, when you try to push something, if the client already has it, we'll just call it a success and be done. Then apps might actually start pushing things, and we might see some use of an experimental feature that we accidentally shipped in RFC.
So I think this issue is going to be hard to resolve without running code, right?
You mean to 6.8?
Yeah.
Well, so for this, I think that we should retain the golem coded set as is, because it's already being implemented by the service worker, and it's also much easier than implementing cookie Kaku filters to implement algorithm code sets. But on the other hand, it will be worth to wait for other experimentations to see whether Kaku filters would be a nice thing or not.
We have someone in line. Barbara.
Comment from Jabber from Mark Nottingham. I've had a discussion with one browser engineer who says they might be trying to implement in the somewhat near future. That's not a commitment. However, I think the question is whether we wait for a browser implementation or ship it as experimental and see.
Yeah, so Martin Thompson, that's really the question that we have here is, I mean, how much do we expect to learn from one person implementing this to the extent that we would change our minds on this? It seems like the question of whether to use Cuckoo or Golem sets is probably one that you can resolve on paper, academically, basically. And so we can make a decision as to whether we want to allow for removals from the set, just based on analysis rather than waiting for an implementation. I expect that any implementation we experience, we might get from this could be quite a long way away. So we either decide to, I think that there's really only two courses as a result of that, which is either park this and park it perhaps indefinitely, or publish it as an experimental RFC and just say, look, this is it. We want to see if people learn something from this.
Yeah, I mean, it seems like the underlying question is whether people are going to implement this at all. And there's a real tendency, I think, to over-rotate on, because these are interesting computer science problems, so trying to figure out the best data structure, there's a real tendency to over-rotate in these computer science problems, but that's not the limiting factor on whether people are going to do that or not. So, and more to the point, like in 2 or 3 years, almost, I mean, Cuckoo filters were like 1.5 years old. So like, most certainly there'll be like Shmuku filters in a year that are even better. So like attempting to like determine the exact optimal data structure, like we should just either park it or pick one and do the experiment and move on.
So maybe we should move on to the next slide. I don't know.
Oh, this is all.
Oh, this is reached the end. So that's great. Thank you. Does anyone else have any further comments on Cache Digest? State thereof? Awesome. So next on the agenda is Origin. I don't know if Mark wants to join us to do that or is unable, or Eric, if you want to pitch in on Origins. State thereof.
It might make sense for Mark to get started because he's been doing most of the active work.
Yeah, I think Mark wants to remain text only is my guess this morning. So we can do, someone suggests we can do text to speech. That'd be pretty awesome.
We can also just start.
Let's see what we got for the issue list here.
I think I was also noticing that possibly there's not an issue to talk about the DNS following one, which I think is something that's certainly worth discussing.
Right, and I have some non-chair sort of opinions on Origin as well. So,
but I think
so which one would you like to start with, Eric? Do you think?
I'll just give the brief summary. There's a bunch of changes Mark made since the last version, in particular around changing the Origin frame to simplify it to be increment or add only. So rather than having a hey, things can keep getting added and removed, it's much more around a set that you keep adding to, which makes it easier to reason about. Along with this, there are some significant changes around allowing, which I think are worth some discussion here, around saying that you are relaxing the requirement for HTTPS cases that you don't have to follow the DNS and that you can ignore the DNS.
Those changes were made in the draft.
Yeah, those changes were made in the draft, and there's security considerations talking about some of the risk factors around that. And I think there's the question of whether or not we want to keep that in and continue to constrain, don't follow the DNS, also relates to a number of the open issues. For example, there's an open issue around should we support wildcards or not. If we follow the DNS, supporting wildcards might be reasonably safe. If we continue to have the, hey, you don't have to follow DNS, then introducing wildcards might be exceedingly dangerous.
Barbara?
Sorry, trying to jabber and talk at the same time. This is hard.
When you volunteered for Jabber, you didn't realize you were channeling the missing chair.
Sorry. So yeah, Mark Nottingham did make several comments. Not sure what yes, I do. I think that was he wanted to stay on text, but then he said should note that we parked it and now we think it's ready to unpark. Okay, I think that's it.
Okay.
So Mike Bishop, one comment on relaxing the DNS portion. So the HTTP2 spec currently says, I believe, that you do check the DNS. If we're saying you don't check the DNS to coalesce regardless of the origin frame, we're now updating 7540. Mm-hmm. Is that a goal?
In fact, it says must not check the DNS.
Even more so.
So it seems like there are two reasons one might want to check the DNS. One is because you want to allow the server to distribute the traffic where you want it to go, even though you're not concerned about security issues, namely that you somehow wildcard serve, but you want a.example.com, b.example.com to different servers, and the other for security reasons. I think there's some real open questions about how much security value you're actually getting out of DNS in the situation. I'm not saying none, but I'm saying there's some real questions about how much value you're getting. So, and the first one does not obtain in this situation because the server is directly telling you where he wants the traffic to go. So it's not. So I mean, the server can send you a stupid origin frame, but that's his fault, not the fault of the protocol. So, I mean, this mechanism divides those two properties. So, I don't know. I guess. I don't know if Nick's in the room. I think he'd expressed some concern about pulling the DNS piece off, but I mean that seems like probably the discussion we ought to have is, do we think the DNS piece is actually adding significant security value?
Mm-hmm. And I think there's two elements to it. There's a security aspect and there's an operational aspect of it's a fairly major change here to now look at how traffic is directed on them, how web traffic is directed, or how HTTP traffic is directed from you always follow through a DNS chain to get someplace, and what ecosystem that builds in around things like multi-CDN load balancers, to now saying you can ignore DNS and anyone who has a cert covering something can get a client to come to it and say, pull in some traffic.
So to the point that servers could load, Ranjit, sorry, I'm Noor. I don't have the badge. The whole point seems to be coalescing connections. So if the server wants to point that to somewhere else, we should find a different mechanism because this is to sidestep that, right? Mm-hmm. So I thought that was the point of the origin frame itself.
Right. So on the point of extending 7540, it's an HTTP2 extension. I mean, that is what it is supposed to do. And they do override provisions in 7540, and 7540 makes that explicitly like an okay thing to do, right? Sure. So it tries to be explicit about what is changing about that for sure, and living in a world where you do not understand the extension. I have done some implementation on this. I want to say one thing. I updated an open source server to generate frames so I could test with my client, and it was sitting on the same code point, which is B11, which one time had been proposed for blocked and forgotten about. So if anyone has an implementation that's going to start throwing protocol error or anything like that, if they see extensions with B coming down the wire, that would be a really good thing to let the working group know. I would think I've talked with the Chrome folks, and they say that's not going to be a problem for Chrome, but just making sure. Go ahead.
So Martin Thompson, why don't we just pick the next number?
It's a possibility.
I mean, yeah, we have a gap in our registry.
We have an external gap in settings too.
Yeah, I mean, whatever.
Whatever. Just one
Pick 73 for all that I care.
Oh, great.
Yeah.
UUIDs, that's what's coming next.
So
yeah, that's actually a strategy that some people have adopted for TLS extensions, which is we're not going to ask the working group or IANA for a code point assignment. We're just going to pick one at random and start using that. I wouldn't necessarily endorse that strategy, but it means that you get less of these sorts of problems.
don't we have a range for experimental?
Well, yes, they do. But then if you actually want to standardize the thing, then you have to change the code point, and then that's awkward.
Mm-hmm. So Mike Bishop, one other comment on checking the DNS. So I know in terms of trying to talk about deployment of the additional search draft, one thing that we have on our services, and I know Akamai has the same thing, I assume most other servers do as well. If you have multiple host names, you probably have multiple IP addresses for them that don't overlap because you still can't quite give up on those clients that don't support SNI. And so if you connect to any one of those IP addresses, they're all the same server, but they're different cert. And so when we start talking about using the additional search draft in combination with the origin frame, the DNS won't match, will never match.
Right.
Now there's an easy way around that, which is to say all of those origins should give you alt service to the same one, which is I support SNI.microsoft.com.
But alt service is asynchronous and kind of optional, right? Where this is
over time.
Yeah.
Although related to that issue also, I've gotten feedback that it would be, it's a pain that you cannot specify a wildcard in alt service. If you have a cert for star.contoso.com, but you can't alt service star.contoso.com to another host.
So I would like to make a comment on the DNS side. There's also a security, or at least a privacy, benefit to allowing Origin to handle essentially the routing the DNS normally does for you, which is how I prefer to think about it than saying it does DNS. Right. So this literally eliminates lookups that, in point of fact, are probably unsecured anyhow and are spreading a lot of information around the network. There was a Tor-sponsored paper at NDSSS. There are a lot of S's in the conference. That talked about the DNS you do actually exposes, essentially the same as your SNI information to twice as many autonomous systems networks as are originally involved to do transit between the client and the server. So twice as many people learn about it just by spraying the DNS information around the network. And so to the extent that you are not resolving DNS, that's a good thing. The DNS folks are working on QSET minimization and some other things that help on that front as well. But I actually view that as a significant benefit of Origin. We have a lot of folks here who are active in the TLS space, and I'm, obviously, Origin is not blocked on secondary certs as it is, but they dovetail really nicely together. And I'm curious if someone would want to update us on the work in that potential work in that working group, or maybe the AD would like to update us on the potential work in that working group, and then what it might mean for future drafts for this working group, which I think my assumption has been it probably involves work in both. So.
I think before we get to that, I'd like to sort of summarize the three main benefits. Following up on what Mike said, if you do have services that are on the same machine that are split between SNI and not SNI, this allows you to use the same connection, which is a great benefit in certain deployments. I'd like to echo what you just said about the privacy benefit of not actually doing a DNS lookup. And I'd like to add a third point, which is that not doing the DNS lookup could additionally provide a performance benefit for coalescing.
Sorry.
I was going to try to clarify the document status. Secondary certs, are you talking about subcerts or the additional certs? Right. So So first of all, I am not the AD for TLS. I don't think we decided to take that on one way or the other. Nick, I don't think you've asked for acceptance yet, have you, for support authenticators?
The call for adoption will go out next week, is my
Yeah,
understanding.
there was a hum saying the working group was interested, but the call for adoption hasn't gone to the list yet.
Right, that's right. My sense is we will take it on, but.
And then on the HTTP side, we have the additional search draft that has a dependency on Nick's draft that I think actually went to call for adoption and then was pulled back because the dependency hadn't been adopted yet.
Can I please remind you to say your name?
Mike Bishop.
And presumably we would want to resurrect.
Yes. I don't know if we ever actually ended the call for adoption. It may have just been in call for adoption for a year.
That sounds like us. So I would say from the implementation side, Firefox is very, very interested in this and would like to probably ship something experimentally soon. I know of at least 4 large server deployments who are very, very interested and have plans to ship as well. So I don't know if they're welcome to speak for themselves, but.
Mike Bishop, I will comment one more thing on the DNS, and the additional search draft goes the other way and explicitly requires you to check DNS. Because if you have a compromised certificate, now I don't have to convince you to connect to me on that domain name. I have to convince you to connect to me on any domain name. And then I show you the compromised certificate.
So while we've got the topic open and we're.
I don't think I'm understanding the reasoning there. So your assumption, yeah, so in the compromised certificate case, right, I have a valid certificate for attacker.com and a forged certificate for google.com. And so your point is I'm going to substitute those two, right?
If I can convince you to connect to attacker.com,
yeah,
then I can claim to be google.com and hijack all future connections to Google.
Sure, but if I can get a bogus certificate for google.com, I can get one that has both attacker.com and google.com in it. So I don't understand how this makes the world better.
Fair enough.
Nick Sullivan, I second that comment. I think that the requirements in origin in combination with secondary certificates should also skip the DNS. And I don't think that's as large of a security requirement as, or a security downside as originally thought.
Kyle Eckertz. I think part of the kind of the point you're making here is that if I steal some certificate that I shouldn't be able to have, I can't really, it's not that easy for me to use it in mass. But if I don't need to also compromise DNS to get people to connect to me, and then I can take over future connections, that really lowers the bar to exploit that in mass.
Eric Nygren, yeah, I think that lines up. Is that right now you have the DNS as a second factor. It may be a weak second factor, but there are a lot of attacks right now that if someone compromises a cert, they still need to either compromise the DNS or have local access to someone's local network or to the BGP. And yes, those are all weak controls, but now this makes it a lot easier of they just need to compromise a cert, do a phishing attack, and now they can start sucking in whatever traffic they want to, and you don't get any of the visibility from either the DNS or BGP sides.
So I mean, it feels like there are 2 attack vectors. One attack vector is I can get a misissued cert or I compromise the CA. And as I said, this doesn't offer any security whatsoever against that. Because if I can do that, then I can have any mix of SANs I want. So you're talking about I compromise the private key for a server. Now I compromise the private key for Google.com, and now I can mount a separate attack. That's your point?
Is that if you were to even if in the first case we get a misissued cert, in order to actually utilize that successfully in attack, you need to get the traffic to come to you.
No, but we just agreed like 5 minutes ago that in the case of the origin frame, that we were not going to check DNS, and so if I can get a certificate that has both SANs in it, then you're not going to insist on DNS checking.
And I think these are all tied together. I think these factors are tied together, and I'm still not convinced that on the origin frame it's safe to not.
Right. I guess
to not-
my claim is these have very similar security analyses, so I don't understand they come with different outcomes. I think I could be persuaded, I think, but they should be treated identically in either direction. But when you say machine differently, then like I'd like to understand the security analysis for that.
Mike Bishop, and that's why we're discussing.
Piotr Sikora, Google. So it seems that the design of origin frame assumes that the connection would be made to the same server anyway, but a lot of people use DNS for either GeoDNS or load balancing between multiple CDN providers, and origin frames allows the server to hijack all the traffic, bypassing it.
Mike Bishop, I think that is correct, but that is kind of the point. That if you are connected to a server that is authoritative for multiple host names, even if DNS might have routed you somewhere else for those other host names, you can use that server, and then it's up to that server to tell you whether it is in fact the best endpoint for you to be connected to, or if it would like you to use DNS and go somewhere else. And that's what the 421 response code is for.
Subodh, it seems like the original intent of the origin frame was to restrict the set of origins that a client would coalesce for. It seems like we are conflating that with actually like coalescing connections as a whole, ignoring DNS. So my question is generally, was this the intent? Does this not serve the original purpose unless you actually ignore DNS, or did the whole purpose of this draft change completely?
The scope of this draft has changed in a number of different ways over time. So it's not just in this direction, the pendulum has swung backward. The original intent of this draft was actually significantly more complex than this version, and then it was simplified to the no coalescing, and then it was re-expanded to kind of this midway point, just historically speaking. So I think it's never been totally clear on that, except it is, my understanding is it's intended as an extension to provide refinements to coalescing. And then exactly how you want to scope those refinements has clearly changed over time.
Eric Nygren, and I think there does seem to have been a shift in scope here from the constrict to the expand, and I think to the point on how does this interact with the start pushing. It may be that it's worth decoupling these two issues and looking at there's one specific question of how does this draft work in terms of the original purpose of constricting things. And then I think there's a separate discussion, and I think that Decker's point, it probably is worth having a broader security analysis and discussion on how does coalescing work, and how do all of these things interact together in terms of this, the pushed certs, and what is the security profile there? Do we want to require following DNS or not? Do we want to also have to push DNSSEC records, or is DNS and BGP insecure enough that we just don't care and want to let certs have full power?
Yeah, Martin. So Martin Thompson, I was going to suggest that the notions of constraint of the coalescing space and an expansion of them could be made separate. But that doesn't actually avoid the issue of the DNS question that we have. I tend to fall into the camp that says that if we have a second factor that's as weak as DNS actually is, then we shouldn't be relying on it. We don't need to rely on it. It's not actually adding any extra value. And I say that because you talk about all the cases where the DNS actually acts as a second factor. I'm actually much more concerned about the cases where we have middle boxes on the path that decide they want to do these sorts of things. And those middle boxes have basically absolute power over where your packets end up. And they're pretty common. And at the point that you recognize that those have some play in this space, you have to rely on either going all the way to something like DNSSEC or using something like well, even then with DNSSEC, you're still boned. So, scratch that. So basically none of the options where you end up relying on DNS help you in those scenarios. And so ultimately you end up relying on the certificate. And I think that the certificate is critical in this situation. We talked about encrypted SNI last night, and all of those scenarios involved talking to someone using IP addresses for something else. And so you're still back to the certificate.
So part of my reasoning here is, this working group has never, fundamentally made the security properties about the routing. And you can see that because we don't use DNS all the time. We subvert it with alt service. We subvert it through explicit use of proxy connect tunnels, right? The security is still, end-to-end across the tunnel, and none of that relies on DNS or TCP getting to where you need it to go. And this just, it's always reliant on there haven't been a cert or a key compromise for the origin, right? And this just essentially doubles down on that. But I think that's always been what the model has been built around.
Okay, Patrick.
Oh, yeah.
So I'd like to, this is Nick Sullivan, Cloudflare. I'd like to answer Sabo's question about the motivation of this draft and whether or not it's changed. And if you frame it in the way that secondary certificates is expanding the possible sets of trusted domains for connection, the origin frame is still exactly how it was proposed as a limiting factor. So secondary certs expands the potential range of domains, origin restricts. And it's still a draft that restricts the origins supported on a connection.
So Mike Bishop, I actually would disagree with you, Patrick, that, okay, fine, we have the ability to connect on a proxy, but that doesn't get rid of DNS. It delegates the DNS resolution of the proxy. And alt service doesn't get rid of DNS. It delegates authority to a different server, which you then resolve over DNS. So I think all of the cases where you say we get rid of DNS, we actually just delegate to something else, and DNS is still relied on for some security. I'll grant that it's weak, but it's there.
It's been a useful discussion. Anything else? Thank you. So next we have random access and live content. I think Darshak is going to do the driving today. Or I think the clicker's up front.
Hello, everyone. So my name is Darshak Thakur, and I'm just going to give an update on this. This was discussed at the last IETF and proposed there. And since then, it's been accepted as a working group item. So this is kind of just an update on draft 00 of that. So just to kind of give a background, the reason for this, why we're proposing this, is because of sort of a constraint or a limitation in the range and the content range A, B, and F as defined in RFC 7233. So in that, if you have a specific use case where the client is trying to make a range request from some particular byte offset and the resource itself doesn't have a fixed end, the resource is kind of, the end is moving, so to speak, or it's increasing. And if the client wants to make a request where it wants to start from a particular byte offset and continue to receive whatever is available right now, and then as new data starts coming in, continue to receive it, there's no kind of mechanism to do that in the current content range header, the range and content range interaction. And so this is kind of it's sort of a hack, but it's probably the best hack that we could come up with that doesn't break anything that's out there. So this is kind of, all the past attempts on trying this has kind of died on the altar of practicality. So this is hopefully, save that. And the main thing is we're not changing any of the RFC 7233 ABNF, we're just kind of putting more semantics onto it. So how does it work? So this is a completely client-driven mechanism. So a client typically would start with making a range request, a head request with byte 0 to dash, whatever. And a server that actually doesn't have, that has the situation where the resource is increasing, would respond back with something like this, with specifically a star at the end to indicate it doesn't know it. That would be a trigger for client if it wants to try out, if the server supports it. So the client would then pick some, whatever, client decided large value and send that. That should actually be a GET request. It can be a HEAD, but it's a GET. And if the server supports the mechanism by which it can keep sending back more bytes as they come, it would echo back the exact same value in the content range. That's pretty much it. That's kind of an indication to the client that the server is actually supporting it, and then the client will get whatever bytes are available and continue to receive or continue to read subsequent bytes. A server that doesn't support it, basically all existing servers, so to speak, are required, or based on the ABNF, simply send back whatever they have right now, and that would be an indication to the client that the server doesn't support it, so it will have to resort to polling. Yep. Question?
Yep. Martin Thompson, I believe that the behavior that we're relying on for existing servers is that they will put the value that they have, whatever that happens to be, in that field.
And
now, if they are doing live ranges like they currently have, that's the only choice they have at the moment.
Yeah, correct. Yeah, this is what is specified by 7233.
Right.
This is what a server
Right.
should
So
do.
in the case where the server is actually generating a large stream of bytes, a continuous stream of bytes, it might still try to guess some number, but it won't produce exactly the same stupendously large number
Yeah.
that the client requested. Because, if anyone has that many bytes, then good luck to them.
Yeah. And I guess that's pretty much the idea. So there was a suggestion on the mailing list about initially kind of using defining some specific magic number. The problem with that one is, well, what should be the magic number? And then again, if the server sends it and then a lot of clients, specifically JavaScript libraries, has a limitation in terms of numbers around 2 raised to 53 minus 1, and then you kind of get into the problem of identifying. So what all we are saying is, instead of that, we're just going to let the client decide what it thinks is a large value.
Martin Thompson, do you have anything in the draft at the moment that sort of advises clients not to pick numbers that are too stupendously large?
We have, maybe we can be more clear about it. We have sort of given the indication is like client should pick something that it thinks is reasonably outside, but we can probably put that.
Yeah, I'm just concerned about server parsing of this field and integer overflow and those sorts of concerns. I just simply suggesting that when the client first tries this with a server, it chooses a number that's less than, say, 2 to the 63 minus 1, so that it avoids all of the obvious integer arithmetic problems.
So that we have put in. We have put it to 2 raised to 63 minus 1 right now.
Okay, that's good. Thank you.
So questions, suggestions?
Okay, so there are a handful of open issues, I believe.
Okay. I didn't.
We don't.
Maybe.
That's just my note. Gosh knows if that's really true, right?
All right. So I lied then.
Oh, that's 0. So apparently that 6 handwritten is a 0 digitally. So that's interesting. Do you feel you need more information from or discussion from the working group before we seek to make sure it's had enough review and go to last call? Or
Yeah, I think some feedback from the working group would be good. Some reviewer. We are going to update a couple of things in the sense that we just realized that we can probably be more clear about if server sends something that's not exactly expected, what should the client do, and some error conditions. So we'll probably add that.
So,
yeah. So Martin Thompson, what I suggest is that you open issues for those things, and when they're resolved, just ask for working group last call. I've read this relatively recently. It's pretty simple. It's not very much of a document really, and we've walked through most of the sort of macro level issues.
So yeah, I was going to actually ask the question of the room if we could get 3 people who would be willing to, so we can make sure this had sufficient read and review. And certainly, if you've already done that work, please count yourself among those 3. So that's Martin. And do we have a couple other folks? Excellent. Your name? Thomas. And get another one.
Craig Taylor. Mark says he'll review it in the Jabber.
Excellent. Oh, wait, so Mark says he was reviewed, but Craig, you're not putting yourself on the hook?
So I just had,
Thanks, Craig.
just wanted to ask one more question in terms of, so we have marked this as experimental right now. Is there any, one thing I was, or we were probably wanting to check was, would it make sense to have sort of a link from 70 to 33 that says updates or updated by this guy? So if anybody reading 70 to 33 can also take a look at this if they come to that, if they have that situation, or.
Well, you're not going to be updated by experimental, but
that's why the question would be.
I mean, I would put the question in the room whether experimental is the right status for this.
Yeah.
Yeah. So Martin Thompson, I would be more comfortable with proposed standard if someone had actually tried this on the web. A lot of servers support range requests. It should be a relatively simple thing to do if you have some time to just simply go out there and hit the Alexa top 100,000 or some reasonable number of sites and simply make a request to a random index.html for the first 3 bytes, for the first 10 million bytes of it, and see whether or not you get a range back for that. And a little bit of an experiment in that would, I think, allow us to make this proposed standard, if as long as the results were not overwhelmingly bad.
Yeah, we can probably do that.
Maybe I could recommend that if people feel that would be okay. Otherwise, I think we just have to publish an experimental document and just leave it as is, which is less good. So if someone's willing to do that work, I mean, then let us know.
It can always be published as proposed later, right?
We can always change the status, but that's just a pain. So I'd rather do that now.
Okay. Thank you. Thank you so much. Okay, so that is it for our active drafts, and I think we've got good progress on most of them. So that's terrific.
Can you summarize what happened with your origin frame?
Yeah.
Well, I think, there's going to be some list discussion for, consensus around the DNS issue, right? So this discussion is input into that. And I think we'll probably ask the document authors to, bring that and any other items they feel or the chairs feel, are needed for consensus before going to last call. That's clearly one of them to see if we can resolve. So, I mean, that's not quite ready, but I think it sounds like we're getting down to just a couple of things to resolve. So, hopefully the document will be able to proceed, but it needs some list discussion and consensus. That's my opinion. Okay, so Mike's going to be up. He's going to talk to us about what's going on in Quick, and especially what's going on with the HTTP2 mapping in Quick. I think is the clicker up by you, Richard? While Mike's going up there, all the blue sheets have made it up front. Does anyone still need the blue sheets? Thank you for your blue sheet compliance. I think he's got to be registered.
Okay. Get this a little bit higher.
And Mike, we scheduled 25 minutes for both presentation and questions, and we're running a good 5 minutes ahead of schedule, so you're in good shape.
All right. Then I don't have to blow through this quite as quickly as I did in the Quick working group. So this is an expanded version of the slides I did yesterday. If you were in the Quick working group, some of this will look familiar. But I also stole some slides from Jenna and the session that he did on Sunday. So Quick started out as a Google proprietary protocol experiment where essentially they replaced all of HTTP2, all of TLS, and a large part of TCP, ran it over UDP, and had some really interesting results and lots of interweaving between the layers. In the IETF version, we've been trying to tease those layers apart a little bit, where the crypto protocol is no longer Google proprietary crypto, it is TLS 1.3, incorporating a lot of ideas from Google's proprietary crypto. So their contributions have made TLS 1.3 a lot better, and now Quick is moving to a standards-based option. It's pluggable, we've got congestion control, and then we have an HTTP overmapping that sits on top of it as one out of eventually many application protocols. So trying to make it not be specific to HTTP. It has also been only half-jokingly referred to as TCP2, in large part because it replicates a lot of the things that we have wanted to do in TCP for a number of years and have found to be either difficult or impossible to deploy on the real internet, because middle boxes don't like seeing protocols that they know change. And I don't think anyone in this working group has ever encountered that issue, have we? So, very quick run through Quick. I assume by the end of the week, most of you probably know something about what Quick is. Can I just see a show of hands for anyone who feels like they don't understand Quick at all? Including some people who work closely on it. Okay. Fair enough. So basically, you have a handshake that, kind of like TLS 1.3 with TCP Fast Open, can get you app data as soon as, even in the 0 round trip case. In the, I believe, worst case, you wind up with a 2 RTT handshake. But if you do everything right and you've spoken to the server before, the common case is expected to be 0 RTT. And unlike TFO, you can actually send a full initial condition window's worth of data, not just one packet. So you have more of a shot of getting real requests in. I know when we were designing HTTP2, one of the concerns was we had to do header compression really, really well, mostly because after if you do TFO, you get one packet, and you got to fit the TLS client hello in there. There's not a whole lot of room left to make any HTTP requests. Quick isn't quite that constrained. So conceptually, a Quick packet is an encrypted container of frames, and the frames themselves are what are actually interesting. Loss detection figures out which packets are gone, and then that tells you which frames didn't make it, and you retransmit or regenerate those frames as you need to. So you don't just blindly retransmit a packet that was lost if the information in there is no longer relevant. So let's say a stream has been reset, there's no point in resending data that was sent on that stream, which has some interesting consequences I'll talk about in a minute. Most of the frames are control oriented, everything else is just data on the stream. And the odd numbered, even numbered client versus server initiated streams will look very familiar from HTTP2. So one of the questions that was asked on the mailing list is, what's interesting about Quick and why are we doing this? And Patrick and I had two different answers that kind of touch on the same direction, that it gives us more agility. We can move more quickly and change some things. So I think a lot of Google's initial motivation was, if you do it over UDP, you can implement it in the app layer, you can ship it with Chrome, and you're not either dependent on, say, speaking of Microsoft, getting people to upgrade from Windows 7 to Windows 10 to actually get new TCP features, or from Google's case, getting people to upgrade anything other than the browser where they can auto-upgrade. So both getting things into the OS and getting OS updates rolled out can be slow, app updates can be fast. So you have a potential advantage if you choose to implement the app layer. But I think one common misconception is that it has to be implemented at the app layer. It doesn't. It could be an operating system binary. It could be potentially in kernel. I don't know of any kernel implementations at this point. And also, it gives us more flexibility because the things on the network don't see inside the tunnel. So just like we found with deploying over TLS, you can do things that middle boxes will be confused by if the middle boxes can't see it. So if you look at Quick as a transport, it has some differences from TCP. Noticeably, TCP tries to guard only against accidental corruption. Quick will actually catch the intentional changes of the middle boxes, which is both a good thing in some cases and is frustrating many legitimate middle box cases. And that's an ongoing discussion as to how they should be able to interact more explicitly. Quick is encrypted from the start. There is no unencrypted option. Has a lot of the same features we'd recognize out of TCP. One thing to point out, though, is that when Quick guarantees in-order delivery, it's in-order delivery on a particular stream. There's absolutely no guarantee about ordering between streams, so you can't reason about things that way. But if you start comparing it to the HTTP2 framing layer over TLS over TCP, there's actually a lot of similarity. And that's because Quick was designed to be originally a substrate for transporting HTTP. It pulls a lot of ideas from the work that we already did. And really the big thing that bites you is that in-order delivery. Because HTTP going over TCP, we relied a lot on the fact that even on different streams, things still showed up in the same order. So HPAC frames have to be processed in order. Settings, priority, all of those things make assumptions that everything that was sent previously on any stream was also received previously. So looking at connection negotiation, right now the only way to do HTTP over Quick is to first get an alt service header that tells you that you have an alternative over here on another protocol, and that's HTTP over Quick. There's not currently a way to point to an HTTP over Quick endpoint directly. There's an open issue for that. There are lots of options and none of them are good. So I don't necessarily want to go into that discussion now, but if you want to jump into that discussion on GitHub on the Quick repo, I would invite more people to chime in. It has its own ALPN token. HQ is a little bit of a play on H2. So I can go quickly through the way. Does it work? What was that? Does it work? Quickly through. Oh, yes, yes. Yesterday's working group, we also had a lot of quick questions. So Google's version of Quick and draft 00 put most of an entire HTTP2 session on stream 3. Stream 1 is reserved for crypto, and there's no stream 0. What was that? So just like HTTP2, odd-numbered streams are client-initiated. So 2 is the first server-initiated stream. The question was, where did 2 go? So you ran most of an HTTP2 session on stream 3, and then the bodies were on the other Quick streams. So that was nice in that it let you keep most of the structure of how HTTP2 worked, and it preserved all the ordering requirements. But one of the initial reactions was that's really ugly to have a multiplexing layer at Quick and a multiplexing layer at HTTP at the same time. So in the current drafts, each HTTP request runs over 2 Quick streams. One is used for headers and other frames about that request. The other one carries the body with no framing of the HTTP layer. That means that Quick takes care of all the multiplexing, which is a nice attribute. We also did pull in the extended settings draft that I presented however many IETFs ago, when the immediate feedback was, we don't really need this as an extension, but it's solidly better than the settings frame that shipped with HTTP2. Let's use it in the next protocol rev. Well, here's protocol rev, so it's in. But there are a lot of things that have become subtly different because of that cross-stream ordering. So because of the fact that priority can move entire subtrees around, and you have to know what was in that subtree, priority is not commutative. You can't rearrange the priority frames from different streams and still come out with the same server viewpoint of what the priority tree is. For Quick, that means that priority has moved to stream 3, which is the control stream, and it's not in the header stream, not in the headers frame. For setting ZAC, we went through a what would it take to do setting ZAC and have it consistently, and the result is that you send setting ZAC not on stream 3 or stream 0 like in HTTP2, you send it on every open stream and the control stream. And compared to that, the working group in Quick felt like, you know what, it's not worth this complexity just to be able to change your settings midstream or mid-connection. You send your settings from the beginning and they are that way forever. And if you want to change your settings, you open a new connection, 0RTT makes that cheap to do, and declare your new settings on a new connection. Yeah.
So Mike, just thinking this through at this moment, the server wants to send a settings frame, right? So the server has to somehow kick you and tell you, I need you to reconnect so I can send you a settings frame.
Yes, so the server is able to kill a connection.
Right, but that's probably not the behavior I want, right? I want the behavior I want is you can go ahead with it. You want to make before break. So you want to be able to say, listen, keep doing the thing you're doing, but come back to me now so I can give you a settings frame. So it's a little more complicated than that.
So in HTTP2, that would be the go away frame. And exactly what go away looks like in Quick is still under discussion. But and with the go away frame, you basically say, no new requests on this connection. If you want to make more requests, open a new one.
Sure.
But yes, it is hard if the server wants to change its settings in response to something you've done, that is harder because the server doesn't necessarily have the context on the new connection.
Sure. Yeah. I mean, I guess it seems like the semantics of I'm done, piss off are different from the semantics of I'm done, please reconnect. In particular, if I send you a pile of go-aways, I probably don't really want you just reconnecting right away because I want you to go away. And so I guess my point is that it's unfortunate to have the server not be able to have the client not be able to distinguish between, I really wish you would stop talking to me, from like, I actually love talking to you, but I wish you'd talk to me differently.
Back in HTTP2, there actually was a proposal to have a flag on go away to say, and come back.
No, it was, and don't come back, yes.
Right. Okay.
Yeah. We don't really have right now the semantic of, I don't want to talk to you, right? There's the, I don't want to talk to you on this connection. Sure. And it might be valuable, but that's not something we have.
And I'm just saying that that's made more important by the fact that you can't update settings in flight, right?
Sure. I think the other thing is, didn't we do some analysis on like how often in connection settings frames are actually done, even in the HTTP stack, and it was like basically not.
Yeah, I am aware of one extension that does do midstream settings changes. I own it.
Right.
It is an extension that says, despite what the RFC says, I'm willing to do renegotiation because I have a client cert to give you. And because renegotiation stalls the connection, we don't set that until we have the cert in hand and we could immediately respond to a renegotiate request. Hopefully exported authenticators means we won't need that extension anymore. So I'm fine getting rid of that. And beyond that, we did not hear from anyone who, for example, dynamically changes their HPAC header table size.
Yeah. So Martin Thompson, the other thing is we do have alt service, and that gives servers the ability to push someone somewhere else if they have a somewhere else. The go away and don't come back. Yeah, we don't really have one of those.
Yeah. And then if you think about where we rely on ordering, HPAC is a big one. Right now, we keep HTTP2's HPAC in place. We put a sequence number on every headers frame, and we require that it has to be processed in order all the time, which is not any more head of line blocking than it was, but it does limit how much advantage we can take of Quick when there aren't really dependencies between those frames. So that also creates issues because when you reset a stream in Quick, that data is no longer retransmitted. So if you have packet loss at the same time as the stream gets reset, and there was an HPAC frame in there, you just completely destabilized your HPAC compression state and you have to kill the connection. Right now, our workaround for that is to say, well, that's why we have 2 streams. You cannot reset a header stream, you can only reset a body stream, and you just have to eat headers. It's a little bit unfortunate. There are 2 different proposals right now, and full disclosure, one of them's mine, for making changes to HPAC that would be more quick friendly. I think from the HTTP community, we would really like to have people reading through both of these drafts, and for Buck Krasik's draft, search by his name. The name of his draft changed when he officially submitted it, and that was after I made my slides.
So are you going to expand on those proposals at all today, or?
I wasn't planning to, but I can give you a quick synopsis of them.
I think that would be good. I mean, I think there are a lot of people in this room who will end up implementing wherever that goes. So that might be a useful thing. And it is just my personal judgment of the quick working group that there is appetite for making a change to do better on this head of line blocking problem. So I think, you know, I would want this working group's voice to be involved in that.
Yeah. In fact, if you wanted to pull up my HPAC slides from yesterday that we didn't get to.
Where are they? Where are they?
Quick working group, meeting materials, working group materials.
All right. Just keep talking and I'll do it.
Sure. All right. Well, I did not go into Buck's proposal in my slides, so I will give you the quick synopsis of my understanding of his, which is basically to add some additional state to HPAC to say you're allowed to reference things that are in the same packet. You're allowed to reference things that you know have already been received, and otherwise you have to process them in order. And there's additional state around that. It does, with the additional state and some additional flags on headers fields, it feels a little more complicated, but it has the, I would say, the strongest advantage of that proposal is both of these would diverge from existing HPAC code, but you could still use his encoder on an HTTP2 connection, and just, you always know that the frames have been delivered in order. So you have greater capacity for code reuse there.
These the ones?
Yes. So in mine, I basically said, you know what, if we're going to diverge from HPAC, then let's design for quick. So basically, HPAC is always an append definition. So when you declare something new to go in the header table, you don't say what index it is. The client knows what index it is because it has the same dynamic table and it's in sync. In mine, when you do an insert, you say what index you're inserting to, and that number is explicitly on the wire, so you're not dependent on having received everything in order and deletes having been in order. With HPAC also, you're modifying the table as you're emitting headers, which is what leads to the reset issue. QPAC instead will reserve a separate stream or potentially send headers frames on the control stream. Those do not emit any headers, they only update the table. And on stream is strictly emits that reference the table. So if you kill that stream, you haven't lost any actual state. And also I'm making table management explicit on the part of the encoder that it's your job to stay below the maximum, and you explicitly delete items from the table when you're done with them in order to stay below the maximum. That also means that you're not restricted to just whatever falls off the end. You can selectively delete things in the middle of the table that you no longer need. So basically, you're keeping information about each thing in the table. Oh, yeah, I have this in the middle. So this is the reset problem. HPAC does a single instruction that is both insert to the table and use it. And if you have a loss and a reset stream at the same time, then that packet is lost, and future references to that entry can never be solved because you lost the insert. With QPAC, since the insert is on a separate stream, you can lose the use and use it again on a different stream, and you won't have an issue there. So the way order works, obviously if everything shows up in the right order, you don't have a problem. You have an insert that's on a control stream, you have references on 2 different requests, and then you get a delete that's on the control stream. If the insert gets reordered to be later than one of the references, the reference has to block. There's nothing you can do at that point. So let's say the insert shows up in a later packet because you had loss, you had reordering, then the headers for that particular request can't be decoded until that frame has arrived. If you have a delete that gets reordered, the delete contains information about what streams used that entry. So in this case, the delete comes and it says, we're starting from 0, so beginning of the connection, and I've used this field on streams 5 and 9. And the decoder can look at what the state of its streams are and say, well, I'm already done processing the headers on stream 5. I haven't seen any headers on stream 9 yet, so I can't do this delete yet. So you just store the information in the table, you wait for 9 to arrive, and then you say, that's all the references, I can do the delete now. As far as figuring out when a delete can take effect, the delete says for both headers and trailers, because there could be a potentially large body between those, the value at which you start recording data, and all the streams since then that have actually referenced this entry. And so you can complete a delete when you've dealt with everything before that horizon value and everything that was listed in the delete instruction. And the encoder will respond and say the delete has completed once that's met.
Yeah, Martin Thompson, I noticed that you have not an unbounded memory allocation problem here in the column where you maintain the stream references.
That would be the next slide.
Excellent.
Yes. So it looks like you could attack by simply saying, I'm going to insert a value, and now I'm going to tell you that I have used it on an expansive list of streams. But the thing is, you can always maintain correctness by advancing that horizon value. So all the receiver has to do is say, all right, I'm going to take the last thing in the list you sent me, go 1 higher than that, and record that as the horizon. I've recorded one integer. Actually 2, because then you have an empty set. The horizon value just says, I'm not keeping track of any state prior to this stream, so I have to assume it was potentially used on every stream before that. It makes the deletes take longer to complete, but it means that either side can reduce its memory consumption. And on the encoder side, you probably would not track more than 1 or 2 RTTs ago to begin with. Does that answer the concern, Martin? So basically, dealing with header compression is a question of what trade-offs we want to make. How far are we willing to diverge from HTTP2? Do we want to have completely shared code, or are we willing to have separate code bases in the name of getting better performance? And also, there's a question of, a lot of this is to deal with reordering, which, based on data that has been shared by Google around Quick, they see reordering on a relatively small percentage of connections, but when it does occur, it's very, very painful. And so, are we trying to improve the median? Are we trying to improve the 95th percentile or the 99th percentile? And that's really a design question that we have to make. That's all I have on HPAC.
Maybe pause for comments just on the HPAC issue, or we can take them at the end certainly as well, if anyone has anything. So I would just add support that I think this effort is important, that the data I have shows that this impacts a fairly small tail. So when we talk about there still being a head of line problem that, is loss and reordering oriented, that's that's totally true. It's a little less clear, because I don't have as much quick data. I got a lot of HTTP2 data, right? A little less clear how much of that is impacting message bodies versus headers, because that's going to be the trade-off here. So I'm unclear how much we've already solved, but my intuition is still that this is an important part of the problem.
And document editor's hat on, I will point out that all the discussion around the QPAC draft there, that's me as an individual contributor. That is not an adopted draft in the Quick Working Group.
Right, and it's not fair to characterize Buck's draft for him, but it has a number of architectural similarities.
Yes. It shares code. It can share code with HTTP2's HPAC, where mine is completely a separate beast.
So I don't want to hijack your presentation, but there's a little bit of a segue here to the mailing list thread you started that really talked about somewhat driven around the IANA registry considerations that Quick had been talking about, but how tightly we want to do those things. So I just want to make sure that was covered. Thanks.
Is that worth talking about here? Sorry, Martin Thompson. Do you want to spend some time on that?
Well, yeah, that was my suggestion. But I think if Mike's got some slides, we have some discussion time. So,
I think this is my last.
Do you believe that's worthwhile talking about here? I do.
I think so too. Yeah.
So in the latest HTTP over Quick draft, I incorporated a request and actually a mandate in our charter to talk about how HTTP2 extensions come to Quick. And the original thought was, well, if it's a frame or a setting extension, it just comes across. But the problem is, it turns out that a lot of frames do make some assumptions around ordering. If nothing else, you're sending on stream 3 instead of stream 0. So the current state of how you do extensions in HTTP over Quick, Quick has a single error space that is divided up into application region, TLS region, transport region. And so since it's not the same error space that HTTP2 had, there is now a separate HTTP over Quick registry that if you defined a new error code as an extension to HTTP2, you just need to go redefine that error code if it's still applicable in HTTP over Quick. Currently, the HTTP over Quick draft modifies the HTTP2 IANA registries to add more columns to say, is this frame and also this setting supported in HTTP2, HTTP over Quick, or both? And then it has columns for, if it's in HTTP2, where's the spec for that? If it's in HTTP over Quick, where's the spec for that? But the thing that you run into is, of the frames defined in RFC 7540, none of them are the same now. Every single frame has had at least some change. Either it's not an HTTP over Quick, or it's on the control stream instead of on the request stream, or some bits are different length. It's really kind of a different protocol. And on the settings, half of the 7540 settings are not used in HTTP over Quick because they control things that the transport does, not the HTTP layer. And of the one that's left, because of the way we've defined Booleans, the enable push option is disable push in HTTP over Quick. So a discussion that we were having prior to the publication of this last draft is, at what point do we simply sit and throw up our hands and say, these are two different protocols that should have separate IANA registries? And obviously they are closely related protocols. So far, we are, for the frames that don't exist in HTTP over Quick, those frame values are reserved. For the frames that do exist in both places and are simply variants of each other, they have the same ID. And even if we diverge, I think that is still a goal. And we might even put text in to IANA recommending that if there's a correlation with an HTTP2 frame, attempt to assign the same ID. But ultimately, I think we have to decide whether these are variants of the same protocol or if they are related protocols. And I would welcome feedback from the working group on that, because I think that's not a decision that the quick working group can make on their own.
So we had some mailing lists, just discussion of this topic. I'm a little surprised no one's running to the microphone.
I said what I have to say in the mailing list, which is I'd like to keep these as close as possible, and is that there's overlap. I guess I would say that it doesn't seem to me that the notion of having one IANA registry with multiple columns is particularly difficult. And what's important, now that said, I don't think having two IANA registries is particularly difficult either. What I care about is the semantics of the messages, and thinking the messages should be the same when possible. So I guess, you know, this seems like the kind of like thing that one bike sheds at the very end of the day. And so if we, I mean, I think it's worth discussing the question of whether we think we're trying to keep the semantics of the messages as close as possible and reuse where possible. And if we don't think we should do that, then we should discuss that. If we agree we should do that, then I think we should just like leave the IANA crap for like, you know, like 2 years from now.
Jabber, Mark Nottingham, I think that the overlap is at the HTTP semantic layer frame types. Error codes are below that, and using the same registry is going to cause confusion.
This is Roy. I agree with that. If there are field value or values for the frames, for example, that are valid in H2 but are not valid in Quick, then you don't want them in the same registry.
So Martin Thompson, I agree with Roy and Mark on this. What we have in a couple of these cases is actually semantics that are very similar. They have the same goals, and we certainly might want to put that in text saying that these share similar goals, but they're subtly different in dangerous ways, particularly now that you have header frames that contain different sorts of HPAC. And there was another example, but it's Friday morning, so I'll just leave that for later.
So if you pull up the latest HTTP over Quick draft, one of the big additions there is a H2 considerations section. And one of the sections within that is a listing of all the H2 frame types and how they are different in Quick.
So Ben Kaduk, if you're going to have the situation where you have things that are very similar and have subtle differences that are dangerous, it's probably worth throwing in some extra gratuitous differences in there just to make sure people are using the right data types for the right variant. And so maybe having the numbers match up is not a good idea.
That's also an option.
From the Jabber, let's see, it's Stefan says, it's useful to have extensions for one or the other without taking care of both at this time.
Yeah. So Martin Thompson, I agree with that thoroughly. And the intent is as much as possible to be able to take things like the origin frame and port them to both protocols without too much mess. And so that's why it's kind of attractive to think that you might have the one registry with the one set of code points. And I think though that there's a hazard there, particularly when you have the simple ones which you can implement and deploy and they'll work successfully without any changes. But then you look at something like what Mike's proposed for the exported authenticators use, and I'm not as certain that something as complex as that would be as clean to port across. Might just work if we're careful.
Yeah.
In which case, that document can register two entries in two different code points in two different registries, and I think we'll be okay.
I think it mostly works because everything that depends on order should be on the same stream.
Yeah, I mean, I guess I still feel like there's some confusion about whether the registry issue is getting conflated with the semantic issue.
I think the semantic issue is really the one that we need to concern ourselves with. As you say, the registry issue is just symptomatic of that discussion.
I mean, I think, we have a similar situation with TLS and DTLS, and I think we've done a relatively good job of having things have the same semantics between them, even though there are subtle differences. And, And when you talk about doing new things and pointing to them, actually, that's exactly what I don't want. What I exactly don't want is people to say, we're define new, we're going to, is that, starting 2 years from now or 3 years from now or whatever, we're going to define new things in HTTP, and then only as an afterthought, someone will a year later think about porting it to Quick. I want them to be done, I want them to define simultaneously for both protocols. So that's precisely what I'm trying to avoid is porting.
So channeling Jabber for Julian Reschke, this question reminds of the common field registry between email and HTTP. And Mark Nottingham says, good point, that hasn't turned out so well.
Yeah, so Martin Thompson, I think that DTLS, TLS is a particularly bad example because they both define extensions to the header, no, to the handshake, and the handshake actually has largely the same sort of semantics. You're looking for key exchange. And DTLS goes to great extents to provide exactly the same sort of underlying behavior, which is that you get in-order delivery and no loss.
Eric Nygren, and I think one thing we'll also want to keep an eye on here is that TLS is at least one working group. Here we have 2 working groups, and ideally, I think we'll need to think about as we're going forwards, how do they work together? Because if you want to add something in both places, does it mean 2 different drafts and 2 different working groups, or are the working groups and the chairs going to be comfortable with drafts in either one, going and adding a features and new frame types to both in the single draft?
Well, for the moment, it helps that we have a chair in common.
Do you have more?
This is just a wrap up.
Gabriel Montenegro. Yeah, I tend to agree that having the option to maintain things separate would ensure sanity later on. I can give a data point of something we did in the 6LO working group, far away from applications area, but we had a similar situation in which we had a mental model applied to different, in our case, different link layers. But this is something, so we have a similar mental model applied to 2 different cases. Maybe there'll be more in the future, we don't know. And in that case, we found it useful to maintain the same codes, even as we applied across different link layers. But we also found it necessary to have the option to not do that also. We added a paging mechanism. So in page 0, it's defined as we initially defined it as, for example, in this case, HTTP2 defined it. And we have the option for certain link layers to say, yeah, for some operations, we'll use page 0 because we don't need to depart. The other ones will use a new page and define stuff there, and so on and so forth. I'm not sure you need that complexity here. No. It might just be good to say, hey, it's 2 different ones and be done with it.
I could maybe see siphoning off, and just thinking out loud here, siphoning off a part of the frame space and reserving it for frames that only exist in HTTP over Quick. But right now, there aren't any of those.
So, Mike, thank you very much for this.
I think we have
we got more.
This is just going to Jim Roskin, going back to the question of reordering. It's often the question that people wonder, like, is this really someone off on Mars who's getting reordering, and does it really happen to me? And I would note that you're trying to understand these statistics, and you hear it's a very infrequent thing. So if you all like some anecdotal data, if you use Chrome, some of you I've heard do, you can go to about : histograms, and you can search for the word order, O-R-D-E-R, on that page, and you'll find several histograms relating to reordering, which are counting how often it happens to you and the extent. I think one of them actually has max reordering, which tells you, if I'm correct, you can always search for these things in the Chrome source code and see what it really defines it to be. But I can see, just glancing, something called quick session max reordering time, which I think is a proportion of RTT that a packet comes out of order. I can see 15 on my sitting here. So I'm just commenting that it really is something that happens, and just anecdotally, the expectation is because some routers are multi-threaded, and even though you have typically direct routing, you actually get reordering as you pass through these drives. Just a comment as people are trying to understand the nature of reordering. Google could bring large bodies of data that they've aggregated, but you can at least anecdotally look at your own machine, see if it happens at your company on your site. Okay, that was all.
Yeah, thank you, Jim. That's good input.
That's very interesting. Thank you. And thank you, Mike, for bringing this work here. Like I said, this is going to probably be a recurring theme for this working group. I know there are some other things we didn't get to quite touch on, like how connections are closed down, may have some HTTP semantics moved into it and things like that. So that's worth maybe paying attention to or potentially hearing about in Prague if that's still ongoing work. So we are exactly on schedule. And but one of our last two presentations is canceled. So we have a speaker, Feng, going to come talk to us about the cross-layer interaction of HTTP2 and how it deals with connection management. And you have an extra 5 or 8 minutes because our last presentation is canceled.
I'm Fan from Indiana. So this is not a IETF draft yet.
You're going to have to speak right into the mic so the remote people can hear you.
Sure. Yeah, so this is just some recent work done in our research group, and we think it's probably useful to do some outreach to the HTTP2 community. So the motivation is, so basically this work relates to how the TCP connections should be managed for HTTP2, which uses multiplexing. So the motivating example, so we did some very simple experiment. We set up a emulated network, 10 Mbps bandwidth, 50 millisecond RTT, and we compare between HTTPS using 1.1 and HTTP2. So we first download each file, small file, basically like a 10 kilobit file. Individually, you can see that in the first row. So basically, the two protocols have very similar performance. The download time is essentially 1 RTT, right? Because the file is small and it can fit into the TCP initial context window. But the key difference is the second row, right? So we, while we are downloading the small file, we download a large file in parallel. So we can see there are huge performance difference between HTTP 1.1 and HTTP 2, right? So the small file download performance, while there is the ongoing large file download in progress, I mean, the difference, performance difference is like 70 times. We did some measurements to find that this can frequently happen in real world. So more than 14% of Alexa top 1500 websites, they have some large file just within the top 3 levels of the landing pages. So it is very likely that the user will download a small file together with a large file in parallel. So what is the reason? So it relates to the cross-layer interaction between TCP and HTTP2. Right, so we know that TCP may use a large sender buffer, right? So if you search online, so there are some like tutorial of how to optimally configure a server, and many tutorial basically recommend that you set a large TCP sender buffer size, for example, several megabytes. So by default, this TCP send buffer is always FIFO. So suppose we have a large file download in progress, right? So this large TCP send buffer will be filled with this large file. Right? So the pipeline is full. Then if we download, if the client requests for a small file, right, because HTTP2 uses multiplexing, so the small file and the large file will use the same TCP connection, right? Because the TCP send buffer is FIFO, the small file will be appended to the tail of the TCP buffer. So the small file cannot be transmitted into network until the large file, basically until the queue has been drained, right? So draining this large TCP send buffer may take a very long time, given that the TCP send buffer may be very large. Right, so this is a problem. So then let's think about how to mitigate this, right? So ideally, we want to download the small file and the large file using separate TCP connections, right? So in that case, we can eliminate this sender-side header blocking problem. But it is difficult for the client to just issue two connections, one for small file and one for large file. Right, so that is because when the client making a request, so the client usually doesn't know the size of the object, right? So this option doesn't really work. So we know that like HTTP2 and Speedy, they have this stream prioritization. So of course you can prioritize the large file over the small file, but this doesn't help because this header blocking happens at the TCP layer. It's like in the operating system of the in the kernel. Okay, so this doesn't really help. Then we basically propose a solution. The basic idea is to do stream migration, right? So if the server detects that there's a large file, then the server will migrate an ongoing stream of the large file to a different connection in order to eliminate this sender-side header blocking problem. So I'm not going to discuss the detail of our proposal because I have only like 10 minutes. So the typical usage scenario is like this, right? So first, the client will send one or more HTTP2 requests to the server over a multiplexer connection, right? So then usually the server knows the size of these different requests, right? So if small and large objects are multiplexed together, the server can do a migration large objects to separate connections, right? So therefore, each large object will use a dedicated connection. So in this way, we can eliminate this sender-side header blocking, right? So in some cases, if the response size is not known, for example, if you're using this chunked mode, so then we can also do migration, but using some threshold, right? So if the server already transmits this file for X kilobytes, right? So then it's very likely that this file will be large, so it will be migrated. So how to design this extension? So we also just briefly talk about this design. So we introduce a new frame called a migration frame, right? So obviously the purpose of this frame is to express the intent of initiating a stream migration. Basically, the sender, like the server, basically says that I want to migrate this frame indicated in the stream identifier to a new connection and a new stream, and basically to a new stream in a new connection. Right.
So I think we've got a question. Do you want to take clarifying questions as you go, or would you prefer people wait till the end?
Either way is fine.
Okay. Well, then why don't we? Okay.
Okay, so I'll quickly finish it. So basically, one thing we need to guarantee is that the correct ordering, right? Basically, if you send X bytes in one connection and the remaining bytes in a different connection, because TCP doesn't guarantee the ordering across the connection, we need some way to synchronize, do synchronization. Basically, guarantee the receiving order is the same as the sending order, right? So this is guaranteed by this this frame and its flags. So also we support different ways to initiate migration. For example, the migration can be initiated by either a client or a server, right? So the easy case is that we already have an idle connection. So the migration can already can immediately be performed, like in this plot A and B, right? So if there's no idle connection, then either the client needs to first establish a new connection, then the server or the client can do migration. But the high level idea is we support the migration be initiated by either client and the server. Yeah.
This is Roy. Can you explain briefly, how does the server know that the client is the same client on both connections?
The same client on both connections. So what do you mean?
I mean, you have two open connections between the client and the server.
Right.
How does the server know they're the same client?
When the client make initial request, the client will embed like a client ID in the initial request, in the initial connection. So we need some identifier for the client so that the server will know that they really belong to the same client. So
that's something you add to the protocol?
Yes, we need to add as an extension to the, yeah.
Mike
These are some
Bishop,
details like in the paper.
There was a connection ID in the frame on the previous slide.
Right.
Didn't see it.
Just Jim Roskin, just following on his question, how would you know? One interesting question in a deployment, how would you cause a second connection to arrive at the same machine? I'm not, if I'm understanding what you're suggesting, two parallel TCP connections.
Right.
In a lot of cases, load balancing, it's not at all obvious to me that this rendezvous would even happen before you'd be able to prove the correctness. So I'm just trying to follow up on his question. Thank you. Can you?
So basically, it's TCP is end-to-end, right? So the client just knows that it's the same server.
It's not. Mike Bishop, you've got load balancers. So the client sees one host name, one IP address, but there are multiple machines behind that IP address. You're not guaranteed to hit the same one.
And
I see. Basically, like in a data center, there's a front end. The front end need to redirect this connection to the same server, right? Yeah, I guess this is something we haven't really considered because it's like still early proposal. It's a research paper, yeah.
And following up on what even more significantly, your second connection would typically have a distinct egress port from the client, and it's common that egress port is a participant in the hashing algorithm. So it's just something to think about, as you say.
Right, right. We need to think about this. Right.
Noticeable problems potentially.
Right, especially like in a data center like Google, how to make sure that the two connections end in the same server. I think, yeah, it's good recommendation. Yeah. Okay, so there's some other design consideration, the details in the paper. So the overhead is low, and we can basically the extension can strategically manage idle connections. Basically, there's a trade-off, right? So if you maintain more idle connections, there is some overhead. You need to maintain the connections. But if you don't maintain any idle connection, I mean, there's some overhead you need to pay when you are creating the connection, right? When you doing a migration. And you can apply different migration strategies. And also the scheme also works with HTTP2 server push. And finally, we don't think there's a new security vulnerability introduced by this extension. So we did some prototype implementation, build our own client and server because it's difficult to directly modify the open source HTTP implementation. And we add our own extension, just add this to our own prototype implementation on the server and the client. So the evaluation setup is kind of typical. We just use a typical client and server, and we test in both emulated network and the cellular network. So we consider different migration policy. So this no mag, obviously the extension is not used. The migration can be started by either the client or the server.
So I'm just clarifying. So as part of the workload, what is the buffering size of the server?
The buffering size, we just use the default buffering size for Linux.
So it's huge.
I mean, Linux uses some dynamic management for the buffer. So I think default is like several hundred kilobytes. But when the file is large, Linux will automatically expand it to like several megabytes. Yeah, we just use the default setting for.
What was the server?
Server is just a typical commodity server. Yeah. Software, yeah.
No,
here.
Mike's asking, is it HBD? Is it Nginx? What server software is it running?
Oh, the server, we just wrote our own.
Okay.
Right, but it's fully conformed to the HTTP spec. Okay, so here are the results.
I'd like to see that.
Edgar's comment was it would be the first one that was.
Yeah, so here are the results. Obviously, we can reduce the download time for the small file significantly, like by 90%, using either approach for migration. So this is tested over the wired network. So the setup is 10 Mbps link and 50 millisecond RTT. So also tested on cellular network over some commercial LTE network. The results are kind of similar, and LTE maybe brings even more benefits because the server will further inflate the standard buffer. And meanwhile, the large file download performance is not affected, right? Because compared to the large file, I mean, the small file, which is usually delay sensitive, I mean, the size is small, right? So the large file download is not affected. Yeah, so just to summarize this work, so we propose some extension that basically allows the client or server to migrate an ongoing HTTP2 stream from one connection to the other. So the purpose is to eliminate the sender-side headline blocking problem, right? So it can reduce the delay-sensitive file download time by up to 99% when we have these concurrent transfers, right? Which may frequently occur in real life. And also there are some other benefits and usage scenarios, I mean, in the paper, and we are trying to come up with a draft, but still in the early stage. Yeah, that's all, thanks.
All right, so thank you for bringing this. I'm going to put myself in the queue as well, like Kazuho, but you've been waiting a long time.
Piotr Sikora, Google. So I believe the correct solution to this problem is actually just lowering the sender buffer so that all the frames stay within the web server and it can reorder it.
Right, obviously you can reduce the TCP sender buffer, right? Because in Linux you can just reconfigure the sender buffer to a small one, but usually it sacrifices the performance, right? Because the TCP congest window will be throttled by the sender buffer size, right? So if you set this too small, I mean the TCP congest window will become small as well, so the download performance will be affected. We actually also did some tests. What if we just reduce the TCP sender buffer? I mean, sometimes a large file download performance will be affected. And also, like in most like cellular networks, the network condition is highly variable, so it is really difficult to come up with the optimal value of the TCP sender buffer.
So,
regarding the adjusting the size of the sender buffer, starting from H201 version 2.1, we dynamically adjust the sender buffer size so that it would exactly match the size of RTT, so that there's the exact amount of data that can be sent in one RTT. And my understanding is that other server vendors are also interested in taking that approach.
Okay, but again, my point is that dynamically adjust the sender buffer is difficult, right? Because it's really difficult to predict the network condition change, right? So if you are, for example, you own a car, accessing the cellular network, right? So the network condition is highly variable. You really need to do very accurate prediction of future network condition in order to set the right value of the sender buffer.
Well, so what actually we do is that we don't predict, but we instead we instead obtain TCP info to see the exact amount of data that can be set at that moment.
Right.
Yes.
So I mean, I just checked myself in the queue. So I think determining the right, we're basically looking for BDP here, right? And that's a hard problem. It's a hard problem for the operating system. And we've made it a hard problem for H2 implementers who are operating, fairly high in the stack, fair ways away from that information, right? It's my hope that quick implementations have a tighter feedback loop and can do a better job. But I think Kazuo makes a good point that while it is challenging, it is not impossible. And if your requirement is essentially the same, right? You have to update implementations to either do this somewhat non-intuitive extension that involves, creating more streams when HTTP2 is trying to create less streams, or, getting better priority and buffering. So I think the amount of deployment work is similar. What I did want to ask you is if you did any survey measurement to try and figure out, in the real world, what people are doing for buffering, because it's my data suggests that a lot of servers are commonly exhibiting this problem, and I think we disagree on how to solve that. But I wonder if you do have some data on how big of a problem it is in practice.
Right. So ideally, we want to do some cross-source measurement. So this is actually our ongoing work. Doing some cross-source measurement to see, for commodity servers, what are their behavior in terms of sender buffer settings. And also, I think the more important factor is the user behavior, right? So how often does a user request do such workload of parallel small file and large file, right? So one point I need to mention is that if you do a HTTP proxy, so this problem will be even worse, right? Because for HTTP proxy, HTTP2 proxy, basically all traffic from the same user will be multiplexed onto the same connection, right?
I think Mike, then Jim.
Mike Bishop. So my comment was similar to Kazuho's, that both Windows and Linux expose that information of how much data you need to be giving to TCP for it to keep the connection saturated.
Right.
And so I know our server implementation only gives TCP that much information at a time so that we can react to priority measurements. I would be interested, like Patrick said, to see what sites and what implementations take advantage of that and which ones don't, because I know Windows and Linux both make that available.
Okay, so actually we did some tests. The test was like last summer. We test several HTTP2 implementations, including NG-HTTP2, Lightspeed, Nginx, H2O, and the old legacy SPDY3. So they all suffer from this problem, although the severity may differ, right?
Ben Schwartz. Oh, sorry.
Although you're calling it head-of-line blocking, Jim Roskin speaking. Although you're calling it head-of-line blocking, I almost feel like this is the instigation of buffer bloat within the server sender.
Yeah, it is the.
As a result, there's a general feeling, I believe, I hold it, I think a lot of it, that issues of congestion control, we shouldn't try to change the system at the higher level. Traditionally, I mean, there was this problem in the Wayback Machine. We only had the initial congestion window of 2 or 10, and then all these HTTP guys were cheating and saying, let's open extra connections and we'll beat the rap. And then they said, well, okay, you can only open 6. And they said, okay, I just created 12 more sites that happen to be friends. And so suddenly now I have an initial congestion window of 4 bazillion. Although I haven't broken the rules, I think this is a bad direction. I'd argue that to the extent to which this is a problem, I think it's wonderful you're bringing it forth. I'd argue that things like buffer bloat reduction and so on should step back and think about how they could provide us with prevention of a bloat occurring at the server side at a lower level, and it should not be addressed at the HTTP level. That's
sure, yeah. It is indeed like on-host buffer bloat, right? So most of the previous work just to focus on the in-network buffer bloat, using some algorithms to mitigate that. So this on-host buffer bloat really received very little attention. I think we should, find some way to fix it.
So I got to cut mic lines, but go, guys.
Hey, so just to expand on points made by Mike Bishop and others, on Linux, the name of the socket option you're looking for is TCP not sent low watt. And it is a low watermark setting for unsent data in the TCP buffers that you can allow the operating system to send as much as it needs to and get a notification when it's running close to running out.
So, but do you know whether this option is widely used by servers?
It's recommended in at least some documentation for implementing HTTP2 servers.
Okay.
Piotr Sikora, Google. Just to add to your comments on issues with existing web servers, for example, with Nginx, it's as simple as setting send window directive to like 64 or 128 kilobytes, and the issue is solved, basically, and multiplexing works in the real world.
Okay. So thank you again for bringing this here. That concludes our meeting. We'll see everyone in Prague.
Can I make a comment on the connection?
Please.
I think that connection migration has benefits because when you have a cache cluster in HTTP1, you could migrate the connection so that the response could be sent from a cache node that contains the response. But with HTTP2, since the requests are collapsed, that's impossible. But if you could migrate the connection, you can migrate one request that serves the large file to the cache node that actually has a content. And we find some benefits of doing that.
Just said thank you. You didn't fucking hammer it. Well, in fact, lunchtime for me, actually.
For you all weekend.
Yeah, it's all focused on the issue of making new associations.
Yeah.
I think you could probably just tweak the section.
I got a lot of work done. Just didn't very many sessions. Entire weekend, 3 sessions for 10. I only had 3 sessions. Entire day, entire week.